Ionization energy. As the name indicates, ionization, this is something related to the ions. When we have a neutral atom, we need a certain amount of energy to remove or knock out an electron from the outermost shell of this atom in order to convert that neutral atom into cation. The certain amount of energy that we required in order to convert this neutral atom into a cation is called as ionization energy. All the atoms that are present in the periodic table, they are different from one another. They have different atomic numbers. So that is why all of them have different ionization energies also. Ionization energy is very important in chemistry. Ionization energy tells us about the stability of an atom, that how much an atom is stable and how tightly the nucleus held the electrons in an atom. Moreover, ionization energy also helps us to understand the concept of valency of an atom. What is ionization energy? As we discussed earlier, ionization energy is the minimum amount of energy that we required to remove an electron from the outermost shell. Why they specify that we always need an atom in gaseous form? Here we have the gaseous form and here we have the solid or liquid form. In the solid or liquid form, the atoms are bonded with one another. In the gaseous form, the atoms are isolated. Say, for example, this is atom A and this is atom B. Here we have the bonded electrons, and here we have a gaseous atom, and here we have an electron. Now, the hold of nucleus on this electron is less as compared to the hold of these two nucleuses on these two electrons. Now here the hold of the nucleus for these two electrons is much more as compared to this isolated gaseous atom. This is why the ionization energy we require to remove these two electrons from the bonded atom is much more as compared to remove an electron from this single gaseous atom. So we are unable to provide this much higher ionization energy to remove electrons from the bonded atom. That is why we always consider ionization energy for an isolated gaseous atom. Alternatively, we can also state that ionization or ionization energy is the measure of strength by which an electron is held in a place. So, as we discussed earlier, that we learn ionization energy to check the stability of an atom also, that with which strength the nucleus hold the electron in an atom. Factors governing ionization energy. If the nucleus is positively charged, then the electrons are strongly attracted to it. Here they are talking about the nuclear charge. If there is greater number of nuclear charge, if the number of protons are greater, then of course they will attract the electron towards itself more strongly. The hold of the nucleus will be greater in return. So here the ionization energy will be greater. Why ionization energy will be greater? Because of the nuclear charge, because of the nucleus hold. If an electron lies near or close to the nucleus, then the attraction will be greater than the one with the electron is further away. Here, they are talking about the atomic radius. If the radius of the atom is small, so of course the nucleus hold towards the electron is greater, and if the radius of the atom is greater, so of course the hold of the nucleus towards the electron will be lesser. Now here the ionization energy will be greater for the atoms who have small atomic radius. If there are more electrons between the outer level and the nucleus, the attraction forces are less. Here now they are talking about the shielding effect. Here we have first shell, second shell, third shell. The electrons are present here, here, and the outermost electron is here. Now what happens that this electron is shielded by all these electrons which are present between the nucleus and the outermost electron. Now what happens here? Due to this shielding effect, the attraction of the nucleus towards the outermost electron will be less. And here the ionization energy will be also less. First and second ionization energy. The first ionization energy is the energy that is required to remove the first electron from a neutral atom. On the other hand, the second ionization energy is the energy that is needed for the removal of second electron from the unipositive ion. Why unipositive ion? Because we are already done with removing one electron from the atom. So this time the atom is unipositive. It means it has one positive charge. It's a cation. And this is called as second ionization energy, and then so on. Why second ionization energy is always greater than the first ionization energy? Here we can see that we need ionization energy to remove this electron from the outermost shell. Here the number of protons are equal to 3 and the number of electrons are also equal to 3. On the other hand, now this lithium ion is a cation. It is unipositive. It has already a positive charge and one electron is removed from this atom. Now here we have two electrons, but the number of protons here are 3. If the number of protons are 3, it means there is more nuclear charge. If there is more nuclear charge, it's very obvious that the hold of this nucleus for this electron is more as compared to the first one. So what will happen that the ionization energy we require to remove this electron from this unipositive atom will be more as compared to the first one. If we consider any other atom like magnesium, sodium, bromine, any other atom will have the same scenario, that the number of protons for the unipositive atom will be greater, due to which nucleus hold will be greater, and as a result always this happens that second ionization energy is greater than the first ionization energy. Now you can see here in this one that the number of protons here are 3 and the number of electron is only 1. So of course this time the ionization energy will be greater than the second ionization energy. So this is why third ionization energy is greater than second ionization energy, and second ionization energy is greater than first ionization energy. Now let's talk about trends of ionization energy in the periodic table. Ionization energy across the period. As you move from left to right in a period, we know that the shielding effect remains constant as we discussed in our previous lesson, but the nuclear charge increases, and due to this the hold of the nucleus towards the electron will be greater, and as a result what happens that we will see an increase in the ionization energy. Ionization energy of carbon is more than the ionization energy of beryllium. Ionization energy down the group. The ionization energy decreases from top to bottom in a group, because this time the shielding effect is increasing. As we move from top to bottom, atomic radius also increases, shielding effect also increases. Due to this, ionization energy decreases down the group. Here, if we consider lithium, here we have two electrons and here we have only one. And if we consider sodium here, 2, 8 and 1 electron. Now, there the shielding effect is also greater in sodium as we move down the group as compared to lithium. Moreover, the atomic radius is also greater as compared to the atomic radius of lithium. So that is why the ionization energy of sodium is less as compared to the ionization energy of this lithium. As we move down the group, the ionization energy decreases. So yes, this is all about our today's lecture. If you want more such videos, please don't forget to subscribe. Thank you very much.